Hi students, this lesson is on linear, quadratic, and exponential models. Let's say you have some information, a set of data, and you're trying to decide if it can be modeled with a linear, a quadratic, or an exponential function. How do you decide? So we're going to talk about two ways that you can decide whether the data could be modeled by a linear, quadratic, or exponential function. And the first way is to graph the data, and be sure to graph many points. As some of you have found out graphing in the past, you need to graph a lot of points to see that something is a parabola or follows an exponential curve, and you don't just want to graph a few points and assume it's going to be linear or a line. The second thing that you can do is to look for a pattern in the data. And we've done this a little bit by finding first differences and second differences. So we're going to go over that again to see if you've got a constant increase in x and first differences are the same in y, you've got a linear function. If you've got constant differences or a constant increase in x and your second differences are constant, you've got a quadratic function. So let's see what that looks like. All right, so here's an example. The height of bridge suspension cables, okay? We have the x, our x value, our input, our independent variable, is the cable distance from the tower, and the cable height in feet is our output. So if we look at our x values, our input values, we want to see a constant increase. And we see that we have plus 100, plus 100, plus 100. So our x, we've got a constant increase on our x values, or our input. And then we're going to look and see, the first thing we want to see is what are our first differences here. So we are subtracting 256 from 400. Or actually you could take 256 minus 400 and we get negative 144. And 144 minus 256 is a negative 112. And 64 minus 144 is a negative 80. These are our first differences, and they are not constant. So then what we can do from here is go to second differences, and 112 minus negative 144 is a positive 32, and negative 80 minus a negative 112 is a positive 32. These are our second differences, and they are constant. And when second differences are constant, you're looking at a quadratic relationship. So, first differences are constant, you're looking at a linear model. If second differences are constant, you're looking at a quadratic model. And again, for this to work, you always have to have your input or your x values increasing at a constant rate. Let's look at another problem though. So what if you don't have first differences aren't constant and second differences aren't constant, but you still want to see, is there a relationship? And you want to know, could there possibly be an exponential relationship? So let's look at an example of. Okay, so here we have another example of value of a car. We have a car's age in years, and we have the value. We want to double check that our x values are increasing at a constant rate, and we can see that this is plus 1, plus 1, plus 1. So we have a constant rate for our input. So that's number one. If we're looking for a relationship, we have to make sure that we got an increase at a constant rate for our input. So let's look at first differences. And when we go through first differences here, we get negative, we're taking 17,000 and subtracting 20,000, we get negative 3,000. And here I get negative 2,550, and here I get negative 2,167.50. All right, so those first differences are not constant. Let's look at second differences. And here I get 450, and here I get 382.50. So let me just erase that and get it where you can see it. 382.50. Okay, so my first differences are not constant, and my second differences aren't constant. So the third thing that I can do is look for a common ratio. What is a ratio? Well, a ratio means I'm multiplying. Is there a constant number that I'm multiplying the value of the car by to get its value the next year? Okay, so what we can do to find out if there's a constant ratio is we can take the value one year and divide it by the previous year's, by the next year's or previous year's value. So if I have, after 1 year the car was worth 17,000, and I divide that by 20,000, I get 0.85. In other words, I take that 20,000 here and I multiply by 0.85 and I get 17,000. Okay, let's see if this holds. If I take the 14,450 and I divide by the 17,000 the previous year, do I get the same ratio? And I do. I get 0.85, which means if I were to take 17,000 and multiply it by 0.85, that's supposed to be just one dot, 0.85, I get 14,450. And let's do the last one and see if that holds. So I get 12,282.50 divided by 14,450, and I get 0.85. In other words, 14,450 times 0.85 gives me 12,282.50. So there is a common ratio of 0.85. Therefore, it is an exponential function. Exponential functions have a common ratio to get that we multiply the value, the previous value by to get the next value. All right, so let's sum it up. A linear relationship can be modeled by in the form y equals mx plus b, and we know that data has a linear relationship if first differences are constant, and a quadratic data that has a quadratic relationship can be modeled in the equation y equals ax squared plus bx plus c. And we can look at data, and if it has second differences are constant, we know that we can write a quadratic function to model the data. And last, if an exponential relationship looks like this, y equals a b to the x, okay, where a is the initial number, b is the ratio, okay, b is the ratio. It's really, a ratio is really 1 plus or minus the rate. Okay, 1 plus or minus the rate. So that's where that b comes from. Instead of 1 plus r or 1 minus r, we're just calling it a ratio b to the x, where x is the time. And we know when we're looking at data that it's exponential if we find that there is a common ratio. In other words, a number, if we multiply one of our y values by that common ratio, we will get the next y value. And if we multiply again by that same ratio, we'll get the next y value. Okay, and we find that by dividing the value, a y value, by the previous value, and that gives us that common ratio. So these are three things that you can do when you're looking at data to figure out whether the data has a linear relationship, a quadratic relationship, or an exponential relationship. And we'll be working on this together in class tomorrow. Thanks.